Chapter 17 is going to deal with non-renewable energy sources, things such as coal, oil, and natural gas. Non-renewable is really defined as within our lifetime, it's not going to renew. Trees are a good example of renewable resources because we can cut those down and within our lifetime they can regrow. Things like coal and oil and natural gas take millions and millions of years to form, and we're using it at such a fantastic rate that once it's gone, it's gone. We don't have time to sit around for millions of years and let this stuff reform. Little case study that deals with energy, and we learned a heck of a lesson from was in Chernobyl, which is in the Ukraine, Baltic Republic of Russia. They were actually Scientists there were actually running a safety check and shut all their safety check valves off, and that led to basically overheating, and the power plant went kaboom due to poor design and human error, of course. Radioactive clouds were sent over Belarus, Russia, Ukraine, parts of Europe. It's deemed 10 times worse than Hiroshima. Still a dead zone. You can't go back to that area, so those people had to literally pick up and move. Cancer rates are significantly up, about 100,000 people displaced. Of course, had to destroy all the animals and leave all the fields. Is just a terrible situation. Evaluating energy resources, about 99% of our energy comes from heating the earth via the sun. Nuclear fusion is, of course, how the sun operates. We use nuclear fission in nuclear power plants and bombs. We cannot successfully achieve fusion yet on this planet. Indirect resources are things like wind, flowing water, and biomass. Indirect because the sun does drive wind, of course, with convection currents. The remaining 1% is from non-renewable resources like coal, oil, and natural gas. This is a little chart of the world. In the world, about 84% of our energy comes from non-renewable resources: natural gas, coal, oil, and nuclear power. Unfortunately, it's not always going to be here. Only a mere 16% is from things like hydropower, geothermal, solar, and wind, which is deemed renewable. In the United States, we're even worse. About non-renewable resources, about 94%. As you'll see, most of this is actually a political dilemma where certain political parties will push for renewables, some will push for non-renewable resources, so it really depends who's in office. And we use a mere 6% of renewable energy sources. Hopefully that will swing in no time at all. This is a picture of my wife standing in our kitchen. Just a couple stats here. 84% of commercial energy, of course, is consumed from non-renewable resources. That's worldwide. That's what the chart showed you. Fossil fuels, nuclear energy, for example. 50% of developing countries burn wood and coal. One of the reasons that the rainforests are being cut down at such a phenomenal rate is they're slashing and burning. They're burning the trees and forming charcoal. Kind of like charcoal that we use in grills, not quite as refined. It's basically, if you think about the ash that's left over after a bonfire or something like that, that's what they would use to burn. A lot of people around the world realize cook using this, and they also heat their house. The terrible, terrible part of that is the ventilation system isn't always very good, and they can actually die prematurely of things like lung disorders. And many, of course, face shortages, premature deaths, of course, from burning indoors. And again, renewable is, if used, slower than replaced. Worldwide oil usage, if you take a look at the chart, it's gone up quite a bit. Back in the late 1970s, we had huge cars. We were driving everywhere. Gas was cheap. Then we had oil embargoes, which we'll talk about down the road, which caused crashing of systems. In other words, other countries did not send us oil, which was a huge problem. And we are just shooting up and up and up with our oil usage. Keep in mind that oil is not just used to power your car, but it's also used to make a lot of things like plastics and cosmetics. Natural gas usage is, if we continued on this chart, natural gas usage is actually really large right now. Coal is ever increasing. Unfortunately, the renewable resources, such as hydropower down at the bottom, are not being used nearly as much as they should. Nuclear power, too, has really taken a dive. This is in the United States. Of course, we drive our cars and we like driving far. Oil usage has just shot up significantly. Coal, natural gas usage has gone up also. We rely on these as heating sources, as cooking sources, big time. Shifts from 1800 in the United States. Remember, in the 1800s, in the early 1900s, we had, of course, a huge industrial revolution. So we needed to burn coal. Coal was used to not only heat and cook, but it was also used to melt steel. Like all the way from Milwaukee all the way through Pennsylvania. So coal usage really spiked in the late 1800s, early 1900s, and it's kind of gone down since then. A lot of the reason that is because the easy to get at coal and the good coal being anthracite is really being taken already. Wood usage has definitely gone down. Not cutting as much trees down, unfortunately. Um, Unfortunately, in some regards too. Natural gas is really spiking. That's actually going up now too. This is an incomplete graph. The reality is a person in the United States consumes as much energy in a day as a person in the poorest country consumes in a year. So we really like our resources. In 2004 alone, the United States 24% used 24% of the world's energy, so roughly a quarter of the world's energy, with a mere 4.6% of the population. We're a little greedy in that case. India, which has 30% of the world's, or I'm sorry, they use 3% of the world's energy, and they have about 16% of the population. So they're much more efficient, and they really don't use as much energy. Not necessarily more efficiency as far as appliances. They just don't require as much as we do in the United States. 94%, of course, is the United States is from non-renewable, and a lot of these resources, for example, oil, could be depleted by the year 2100, and then what do we do? In the United States, fossil fuel burning is about 80% of our pollution, 80% of CO2 emissions, particularly from cars. Fossil fuels and nuclear energy plants receive government subsidies. That's an issue because it keeps things artificially cheap, and us taxpayers are paying for that. What is used depends, of course, as I said, on political persuasion. So what should we promote? The reality is it takes about 50 years to phase in new energy alternatives. A very promising one is actually hydrogen cars, where you literally take water and split it, and water vapor comes out the tailpipe, and you use that very explosive hydrogen in order to power your car. There are a lot of European countries that are really putting a lot of resources into this. How much is available in the future, of course, is another question, and its net yield needs to be looked at too, because if we're putting more energy into something than what comes out, it's not worth it. Its cost, government subsidies, dependence, does it affect global economy down the road? Is something vulnerable to terrorism too? Nuclear power plants are a prime example of that. We're worried that if somebody slammed an airplane into a cooling tower, that would release huge amounts of toxin into our environment. Transportation, what about the climate costs? If we continue burning CO2 at the rate we do, we know global warming will accelerate. Net energy is a very important topic. We have gross energy and we have net energy. Net energy, first of all, it does take energy to make energy. It's estimating the total energy available minus that's used, wasted in finding, processing, concentrating, transporting, for example, coal. And we do use a lot of coal to heat our homes, and I should say use electricity or make electricity in the Milwaukee area. There is a power plant down in Oak Creek, just south of the Summerfest grounds, that uses huge amounts of coal. Well, that coal is probably mined in the Virginias or in Pennsylvania, so there's a lot of energy that goes into that. Then that needs to be transported through the Great Lakes via boat into our region, and then that needs to be burned off. And of course, the energy that's wasted, it's not a perfectly efficient system. That's the net that we get from it. So ultimately, we don't get pure gross energy from it. As far as energy goes, the best by far is passive solar. Just open up your windows and let the sun come in. Think about in the wintertime in our school here at Brookfield Central, by the art department, that sun that comes in, and you can feel the warmth from it. That's passive solar energy. Heats our houses very effectively, and it's ultimately free. Natural gas is pretty efficient. Oil, pretty efficient, high net yield from that. Active solar, what active solar is, are solar panels. Coal gasification, what they do with coal is they treat it further, turn it into a gas. Electric resistance heating by a coal-fired plant is very inefficient. Electric resistant heating is if you have coils running through a machine. It'd probably be like heating your house with a light bulb, because an incandescent light bulb, not a fluorescent one, which gives off a lot of heat. There's resistance in there that promotes light. It also produces a bunch of heat too, very inefficient. Electric resistance heating from natural gas fired plant, also inefficient. From nuclear power plant, very, very inefficient too, and that's because of the waste of nuclear power, which we'll talk about down the road. High temperature industrial heat. So if we think about heating a big industry or the energy that's used to melt steel or the like or make products, the best source is actually surface mined coal, then underground mined coal. Surface mines number one because it's easier to get at, followed by natural gas, oil, coal gasification, and so on. Transportation, the best form of energy out there that we can use, the most efficient, is natural gas. There are some buses, I don't know if it's in our district or where, but actually that run on natural gas. Next would be gasoline from refined crude oil, in other words, stuff that comes right out of the ground. Biofuel, which is ethyl alcohol. Wisconsin is kind of a leader in making ethyl alcohol. We actually add it to our gasoline. So if you go to a gasoline station, you'll see like 10% ethanol added. It actually makes our gas burn a lot cleaner. Unfortunately, it's not always real great on our engines. Coal liquefaction and oil shale, stuff we'll talk about down the road. This is where oil comes from. If you take a look at this picture right here, oil oftentimes we have to drill deep down into. Generally found above oil is natural gas. It's kind of a domed natural part of it. So when we go for oil, they tend to tap into natural gas. Unfortunately, a lot of times it's burned off as waste, but we are starting to capture that more now. You can see a coal seam right here, which we've talked about before. That's an underground mine, and of course, area strip mining on top is much more efficient. So let's dive into this. Oil is deemed a thick liquid with 100 or hundreds of combustible hydrocarbons in it. In other words, it burns really, really well. It's a very, very high net energy yield as we take it out of the ground, but it needs to be refined in a refinery process that actually lowers the net energy. A third of our energy in the United States comes from crude oil, of course. Events leading to oil, buried sediments, particularly dead plants and animals. What they do is in oceans, the sea floor, which actually creates huge amounts of pressure, more than land does, or terrestrial regions, what happens to that pressure and heat pushes down on those dead and decaying plants and animals, and over millions of years, voila, we get oil collected in porous things like limestone, sandstone. That's a type of rock which is very, very porous. In other words, there's a lot of holes in between it. It's a large particle, and oil can stay in there, so then we tap into that and use it. These are regions in the United States that we're going to talk about a little bit, where we're getting a lot of our oil from. Up in Alaska, there's a huge controversy. There's something called the Alaska National Wildlife Refuge, which is way up on the top here by Prudhoe Bay, above the Arctic Circle. This region right here, we know, has a potential of having oil in it. Fortunately, with wildlife refuges, they're actually protected against mining. However, George Bush Sr., I believe it was, actually signed off on that, so they're doing exploratory drilling. We get a lot of oil from the northern reaches of Alaska right up in here. Valdez right here is an area that had a huge spill a couple years ago, or many years ago we'll talk about. We get a lot of potential areas right up in here. You can see in yellow all the different areas of coal, or coal that we get it from, including in Illinois. This is actually a fault line that runs through here. That's why that's located there. High potential with black here with the oil, and you can see where we get it from up in here too. This region right here, California, has very high potential for oil too, but we do not allow drilling off the coast of California because, believe it or not, a lot of our world's oxygen comes from that region because there's such a huge supply of phytoplankton, which are swimming oceanic little protists, which actually photosynthesize. If we were to have an oil spill there, that actually deplete our world's oxygen supply. So how do we get oil? Of course, it's found nowadays by satellite seismic data. Oil and natural gas tend to be together. It's in a rock. The rock kind of acts like a sponge, It's used to, well, the wells used to pump it up, of course. There is an idea of slant drilling. Slant drilling is a huge ethical issue. Back in 1991, the reason that Iraq actually invaded Kuwait, Kuwait's a little city just, or a little country rather, just south of Iraq, is that Kuwait was slant drilling. In other words, they were going underneath Iraq's land and taking their oil. And of course, that was frowned upon big time, so Iraq invaded them. That's a big no-no because technically a country has sovereign rights to what is underneath their land. Oil and natural gas, of course, is found together under a dome, as was mentioned. 40 to 50% of the oil is recovered. So when we go after oil, not even all of it do we get out because it's just too expensive to get. Drilling does cause moderate environmental damage. It's not the worst thing in the world. It's not nearly as dirty as mining for like coal, but we still don't want them in our wildlife refuges. The extraction, processing, transporting, of course, can cause problems. What if we have oil spills, which we do have? Think about a couple years ago, we had the BP oil spill in the Gulf. These are actually, this was an old picture, these are active drilling sites in the Gulf of Mexico. And actually, we're not drilling there anymore, but look at all these sites are active drilling. There's tons and tons of oil down there. So that would be deemed domestic oil. That all stopped when BP had their big oil spill, the Horizon oil spill it's called. We're not drilling down there anymore. Very few sites because we don't want to have spills anymore. Oil needs to be processed before we can use it. And you can see on the right, there's a picture of what's called the distillery. Or a refinery, if you will. It's a refinery. It uses a distillation process. What they do, there's one, the biggest ones are in Houston. There's one in Chicago. There's one, I believe, up near Superior, Wisconsin. Those are the closest ones. What they do is using a distillation process as they heat the oil. We get things like crude oil out of it that runs our cars, aviation fuel, gasoline, of course, other gases that come out of it. We get things that we can use in our furnace. We get a product called naphtha. We get grease and wax from it. We get asphalt from it. So we get a multitude of products through this refinery process. It's not just the stuff that goes in our car. So refinery, of course, uses the distillation process. It's broken down into components with different boiling points. It results in about 8% of our energy use. The petrochemicals, of course, are used for a wide variety of things: pesticides, plastics, synthetic fibers, paints, medicines. The countries that really possess most of the oil are known as OPEC, which you may have heard of before. There's 11 OPEC countries, which is 78% of the world's oil. Most of them are in the Middle Eastern region. They control the oil supply. Saudi Arabia alone has about 25% of the oil. Now, what's interesting about that is Saudi Arabia was underneath water at one time. We know that because that's where the oil is formed in. Of course, you find a lot of fossils of oceanic creatures there. Very subject to terrorist attack. One of the things that Saddam Hussein did back in 1991 as he left Kuwait after invading it is he burned a lot of their wellheads and sent this black spewing nasty hydrocarbons into the atmosphere from the oil that was being burned off. Canada is very promising, particularly Alberta, and we'll talk about that in a little bit. They have about 15% of the world's oil sand. The 11 OPEC nations, you don't need to know these necessarily, just be aware of them: Algeria, Indonesia, Iran, Iraq, Kuwait, Libya, Nigeria, Qatar, which is where Dubai is, Saudi Arabia, United Arab Emirates, which is a teeny tiny country, very, very wealthy, and Venezuela is a new and upcoming nation that has lots and lots of oil, and we get some of that in the United States, of course, too. Over the years, this is measured in barrels. A barrel of oil is 42 US gallons. It goes up and down. Right now, it's up. You can see it doesn't even spike up here to about $60 per gallon. Now we're up about 80 to 90 dollars per gallon of oil. One of the reasons that is supply and demand. Another reason is it's getting harder to get because we've gotten the easy stuff already. We're importing more and more and more. We do have a solid domestic supply, and that's a big political thing constantly. Do we just rely on our own oil sources and don't worry about the Middle Eastern supply? The problem is we're consuming more and more and more of this, particularly, again, in cars. Traditionally, developed countries are the ones that use a lot of the oil, but developing countries are definitely coming aboard and using a lot more of it, too. It is a very expensive luxury. In the United States, we have about 2.9% of the oil. About 25% of that is from the Gulf. That's kind of changed, of course, since the Deep Horizon spill. 17% is deemed in Alaska's North Slope. We use about 26%, of course, of the world's oil. It can range anywhere from $30 to $100 a barrel. It's a little bit closer, I believe, to $80 to $90 a barrel right now. That does fluctuate with our markets. In 2003 alone, we imported 55% of our oil that we used. By 2020, it may go up to 70%. Again, it depends on political persuasion. Reserves can last up to 100 years. Reserves are, we know they're there, we're not getting them yet. We have about a 50-year supply of reserves in the United States alone. That would be stuff that we could tap into that we would use. That's not a lot of time. At a current rate, Saudi Arabia can supply the world for about 10 more years, which is why they really limit how much is coming out of there. Alaska would supply the world for 3 years. The Alaska National Wildlife Refuge, which I mentioned before, could supply the world for about 5 months, or the United States for about 2 years if we tapped into it. That's the big controversy. Do we really even bother drilling there? If oil usage continues at current rates, of course, the Alaska North Slope, which is not the refugee area, could meet demands for 6 months, or U.S. demands for about 3 years. Again, do we bother going after it? It would make our oil prices a bit cheaper because then we don't have to buy from the Middle Eastern regions. ANWR would meet our demands, of course, for 1 to 5 months. That's new updated data. Or the U.S. oil demand for a couple years, and that's about it. So why even bother? A little bit more about the Arctic National Wildlife Refuge. A very good website to familiarize yourself with is anwar.org. It is deemed a fragile ecosystem. It's a refugee, so a lot of breeding, a lot of nesting goes on there. It's a very, very diverse community of species. U.S. oil companies have wanted to explore it for years. They are doing now. As I mentioned, President Bush signed off on this exploratory well drilling there. Citizens would like the revenue, so people of Alaska really want us to come up there and drill that out so they can make money. Of course, environmentalists are on the other side, feel it's not worth the little oil. Improving efficiency for vehicles would be much, much better. So why don't we just make vehicles that can get 50 or 60 miles to the gallon, which is totally doable? Then we wouldn't even have to worry about it. The advantages of it, it would increase the United States oil and natural gas. It would reduce imports. Of course, it would make jobs, lower oil prices. Not too much environmental harm. The problem is there's a low chance of finding significant oil supplies, as we talked about, so why even bother? It doesn't really reduce much oil imports. And of course, the likelihood of having oil spills. Alaska is a very pristine region of the United States. Should we even bother? Degradation of wildlife is not really worth the risk up there. So oil, in general, disadvantages, we do need to find alternatives. It's not here forever. Lower prices, of course, discourage or encourage waste. And we do discourage making of alternatives. It does create a huge amount of air pollution. It releases CO2 in the atmosphere, which is directly linked to global warming. And it creates a bunch of water pollution because of the processing of it. The advantages of oil, we've got about 100 years supply, if not more. Very low cost, of course, because it's subsidized by our tax money. Very, very high net yield. So by the time we get it out of the ground and actually use it, very, very efficient. Easily transported, a little dangerous though. Low land use, advanced technology. If you go out to places like Texas or even California, you can see on the land everywhere where they have these wells pumping up and down to get oil out of the ground. Just a little alternative is something called oil sands or oil tar. What that is a combination of clay, sand, water, and organic matter, which is called bitumen, which has a very, very high sulfur content. Unfortunately, when we burn this, we want low sulfur content because sulfur gets in the atmosphere and causes acid rain. Bitumen is created when the oil escaped. It's actually degraded by bacteria and water, so it's found a little bit more near the surface. It does require great amount of energy, so to get this stuff, or low. It's got low NPP and it's very detrimental to the land. Alberta, Canada is loaded with this stuff. There's a pipeline that actually comes through Wisconsin all the way from Alberta that goes to a refinery in Chicago area where they're pumping this stuff down. So we get a lot of our oil now. You can see the oil that's inside the basically dirt. We got to get all that out. And we got to process it before we can use it. So Alberta has about 3/4 of the world's amount of this. Another option is something called oil shale. You can see this picture of rock. It's got oil trapped in it. So in sedimentary rock, it contains a very waxy material called kerogen. It's 240 times larger supply than oil, so we've got a ton of this. The problem is we've got to get it out of that rock. It's got a huge environmental impact to mine it, and it's got a very negative NPV because we've got to process it and get it out of this rock. It also has a very, very high amount of water usage.